Okay, so now we're back and we're still on part 5 of the lab, and we're doing the parallel circuit, and we just got finished measuring the voltage. So let's get rid of the voltmeter, and we need to put in the ammeter. We need to measure the current. So how do we do it? We're going to need to open the circuit. So I'd like for you to, on the right hand side of each of the two resistors, open the circuit. So click on the left hand click on the right hand side of the resistor at the junction. Click on the scissors and it's going to open it. Okay, then go down to resistor number 2. And I want you to click on the resistor on the right hand side of the resistor. Click on the scissors. Okay, so now we've completely opened up that circuit. Get out your ammeter and hook it to the right hand side of resistor number 2, and then connect it back to the wire. Nothing should be happening yet. Get a second ammeter out. So go back over there, grab another ammeter. Okay, now this one, connect it to the right hand side of resistor number 1 and then hook it to the wire. Okay, and then hook the top wire, the wire that's coming out of the battery, hook that one also to the other side of the ammeter. So now what you should now have 2 ammeters in the circuit. Okay, so what it should look like is that you got the battery on the top, and then there should be a wire that goes from the battery to resistor number 1, and then there should be a wire that goes from the battery to the other side of the ammeter. So the right hand side of the ammeter. Okay, now what are the 2 currents? So the current going through resistor number 1 should be 0.9 amps. And so in the green box, you're going to, under measured current, you're going to put 0.9 amps for the measured current for resistor number 1. And then for the measured current for resistor number 2, what is it? 0.45 amps. So go ahead and put that there. And then if you want, go ahead and put the total current. So this time you really would add those currents together. So 0.9 plus 0.45 is 1.35. So that would be the total current measured. Alright, now we're ready to find what the calculated currents and the calculated voltages should be. So now we're going to complete the rest of the chart. So in order to do this, let's go back to the notes. So back to your PowerPoint notes. And we're going to go back to slide number 24. And this is how to solve a 2 resistor parallel circuit. Okay, and part 1 says first find the total resistance. Okay, we already did that. Okay, part 2. Okay, it says that I need to move the screen a little bit here so I can see my screen. Alright, there we go. It says in part 2, since in a parallel circuit the voltage is the same everywhere, The battery voltage is also the voltage across resistors 1 and 2. So, the voltage that's coming out of the battery was how many volts? 9 volts. Okay, what is the same everywhere in the parallel circuit? The voltage. So that means we automatically know, without doing any calculations, that voltage 1 is 9 volts and voltage 2 is 9 volts. So go ahead and put that in those 2 blank spots on your lab for voltage 1 and voltage 2 calculated. Alright, now we're ready for part 3 there. It says, lastly, take the voltages that you now know, put them into Ohm's law to find the 2 currents. So on your piece of scratch paper, you're going to write Ohm's law. V equals IR. Okay, but put some subscripts on it. V1 equals I1 times R1. Okay, we know that voltage number 1 was 9 volts. So we're going to say 9 equals, okay, do we know the current? No. Do we know the resistance? Yeah. Okay, resistance 1 was 10 ohms. So we're going to have that, let's see, 9 is going to be equal to I1 times 10. Alright, and now go ahead and solve that for current number 1. Okay, and what do you get? So that's going to be the 0.9 amps. So now you can put that in under the calculated current for resistor number 1. Now let's do resistor number 2. So on your scratch piece of paper, write Ohm's law. Don't just wait for me to give you the answers. So you'll learn the material if you actually do this. So on your piece of paper, V equals IR. Okay, but let's put some subscripts. So V2 equals I2R2. Alright, do we know the voltage? Yes, that was 9. So we're going to say 9 equals, do we know the current? Not yet. Do we know the resistance? Yeah, that was 20 ohms. So now we're going to have 9 equals I times 20. So solve that for the letter I, and what do you get? 0.45. So now you can put that number in its correct spot. And you notice that that matches up with what the ammeter said. Okay. So now let's go back to the lab. We're now ready for the post-lab questions. So you can do question number 1, what did you learn? Question number 2, what's the most useful? Sources of error? Not much. Now, if we were using real wires and batteries, can you think of maybe some problems that there might be with that? Okay, and then how could it be changed to make it better? Alright, let's go down to question number 6. When would you want to use a parallel circuit? Maybe you might want to look that up on Google. Okay, question 7. When would you want to use a series circuit? So what's the advantage of a series circuit? What's the advantage of a parallel circuit? Question number 8. A 5 kilo ohm resistor. So what does kilo mean? It means 1,000. So a 5,000 ohm resistor is hooked up to a 10 volt battery. How much current does it draw? So use Ohm's law for that. Okay, then on question number 9, okay, that one is going to be a parallel circuit problem. So we've done parallel circuits now. If you have problems with this, go back to your PowerPoint notes and go back to slide number 24, and you can use that to answer the question. Okay, and then slide number 10, on question number 10 on the post-lab questions, it says to repeat the question, but now assume that they're in series. So we've already done that. So finish up the lab and then email it to me, and I will see you in class.